Hi everyone. Today I'm going to talk about application of GenAI for all. So if we have a malware file, so the malware file can be related to web application, can be related to desktop application, mobile application. So to understand the file, is it malware or benign? So we have different methods. For example, if you have a PE file or Windows, exe or DLL, so we can have different techniques, static analysis or dynamic analysis. So the dynamic is more related to behavior of the file, can be related to memory analysis or API file, API calls, and about the static analysis related to source code, high level code or low level code. So I'm talking about application of GenAI for static methods. So just for review, when we say the GenAI, so the GenAI can be any kind of the system, AI system for generating a new content by training and learning the new pattern from the text content, video content, or audio content. So currently, the most of the GenAI framework is based on the transformer and attention mechanism. So the most famous one is the large language model. So basically, for source code analysis, we can have two little one non-LLM model or by using the LLM. So by non-LLM can be take advantage of lexical analysis or CFA method. Lexical analysis kind of the natural language browsing techniques based on the dictionary to find the semantic relationship between the terms or the function. By using the LLM, of course, we can take advantage of the attention mechanism or the LLM based on the transformer for semantic code understanding and generation. So, based on the existing work and the previous study, we can have different NLP techniques and LLM techniques for source code analysis. For example, based on for example, pre-training, fine-tuning. The pre-training and fine-tuning is related to large language model, or based on the semantic analysis or similarity analysis to find relationship between the source code and function. For example, we can take advantage of NER or entity detection to find the similarity entity between the source code. And the other techniques is related to zero shot and few shot learning can be also related to L. So again, based on the previous work, we can have different applications of LLM for different applications by using the LLM for source code analysis. For example, for code understanding, for decompiling, disassembling, for summarization, generation, comment generation, security code analysis. So all of them can be helpful to understand a malware application, a kind of application file. Is it malware or benign? By understanding the behavior of the source code, it can be helpful for us to predict the type of the behavior of the application. For the code decompiling and code disassembly can be helpful for reverse engineering. If we want to talk about the reverse engineering tools, for example, as a non-LLM tools, we have either Pro or Ghidra, but by fine-tuning the large language model based on the assembly low-level code, the high-level code, we can also do reverse engineering on the different application, web application, mobile application, desktop application. Decompiling, disassembling, comment generation, code summarization, security code analysis, is a subsection of the code generation. Because code generation is a subsection of the code understanding. So if you have a good fine-tuning of LLM models to understanding the source code, it can be helpful to generate and improve the accuracy of a model for code decompiling or disassembly. So I just try to provide some background about the application of LLM for source code. Now we want to see how we can take advantage of application of LLM for different malware tasks. For example, for malware code detection, family code detection, location code analysis, malware code generation, malware code monitoring, malware code reverse engineering. So for the first task, for malware code detection, of course, by take advantage of existing LLM models and by fine-tuning the malware data set, we can improve our accuracy of the framework for malware code analysis. Also, for the family code analysis, we can consider some same strategy for determine the type of the family of the malware. The other thing is, okay, when we our model they predict and determine the type of the code, is it malware? The other important thing is to understand which part of the code and or which part of the function is the malware. The other thing is related to malware code generation. I think is a huge topic about the malware code generation. Most of our works, we have data set challenge. So I think the malware code take advantage of it, and for malware code generation can be helpful for us to prepare the malware code data for any kind of the application, web application, or application, desktop application. And the other things related to malware code monitoring. Of course, by understanding the behavior of the malware file, in fact, we can have a pre-prediction based on the malware code monitoring to reduce any challenge related to attacks, any challenge related to attacks from the hackers. And the last one is related to malware code reverse engineering. In the malware reverse code engineering, we can have low-level decompiling and disassembling. In fact, convert low-level code to high-level code. The low-level code, it means assembly to high-level code, for example, C++ code, or high-level code, or for example, C++ code to assembly or the binary code, to convert to machine code. So for malware code analysis, we can have different scenario or different environment, as I mentioned, for web application, mobile application, Windows application. So based on the previous study, most of the work they use LLM for malware code analysis for the Android, for the website, for the Windows such as PE5. So here we can see some of the previous work. So most of it is new, is 2024 or 2025. Most of people, they use the GPT models for the malware code analysis. For example, for the first one, they create a data set for fine-tuning the GPT for malware code analysis. Or for the Android, we can see some people, they use Android data set for fine-tuning the model and for Android code analysis. And the other interesting things is about the phishing website. Some people, they had a thousand of phishing prompt to fine-tune LLM model to recognize the phishing detection from the website. The other important thing is related to malware code analysis. So the challenge is if we try to use the existing of the LLM models. So okay, the LLM easily can predict if we have a default or if we have a family. If you have a general model or general malware, the model easily can predict and we can understand what is the type of the family from the source code. A new malware by new patterns, so the model cannot understand, or the accuracy of the model is not good for predicting the type of the family. So we need to we need to take advantage of existing the malware by considering the reverse engineering and to extract the patterns to update and the knowledge of the LLM for predicting the type of the family of the malware samples. Malware code generation is other interesting application of LLM. As I mentioned, one of the big challenges currently is about preparing the dataset, malware dataset. So there is different techniques to generate the malware code by using the LLM. Of course, if easily asked to ChatGPT generate something or generate a DLL injection code or any kind of the query related to malware, the ChatGPT, they stop our query and we cannot continue. So we can take advantage of different strategy and different methodologies such as jailbreaking or writing code. But only there is some challenge after generating some code. Of course, we need to consider some semantic post-processing for refining and validation the samples. The other thing is related to malware code monitoring. So for the malware code monitoring, we can, the important thing is by identify the suspicious patterns and extract the suspicious pattern from the source code, we can predict the type of the behavior of the samples. In the right side, we mentioned about the NER method, this kind of NLP techniques by using the existing frameworks such as the SPACY method or Stanford NLP to extract the entity. When we extract the entity, we can compare the benign entity and with the malware entity to see how is the similarity between the benign and the malware to identify two suspicious patterns. The other technique is related to semantic analysis by using the topic modeling. Topic modeling is other interesting techniques for extract the semantic related word or semantic related function for to find determine the type of pattern, is it suspicious or not suspicious. So the right side is no error, but the right side is error. So we can also have a small language model or the large language model, or we can have a hybrid of the small language model or large language model to identify the suspicious pattern from the malware samples. Of course, there is some challenge. Still, we have some challenge. So, if we have a malware file, for example, a Windows application can be exe file or DLL. After reverse engineering to extract the source code after disassembling or decompiling, sometimes the code is very complicated, so it's not easy to understand the concept of the code. So, in fact, the hackers, they do this for avoiding scanning by antivirus or avoiding scanning by reverse engineering tools. So this is one challenge. So of course, by fine-tuning, also maybe the research topic, by fine-tuning the model, we can improve the accuracy of the model based on this challenge. So there are many works related to Android and APK files. This is a very general framework. So in the beginning, in the first phase, we have the Android file. After that, we have pre-processing by using the reverse engineering tools to extract the source code. So after that, we have feature engineering. I think here is a dynamic approach to extract the API calls. So after that, we have model training, the model fine-tune based on the feature from the Android file. Finally, the model can be able to make a decision if it's malware or benign. This framework is much better to understand about the source code analysis. So here, in the first step, we have pre-processing. We are use the reverse engineering tools to extract the source code from the Android file. So after extracting the source code, after decompiling and disassembling, we have take advantage of existing different elements, for example, CodeLlama, StarChat, CodeTFI, or PLBERT for source code analysis. So in the in the output of the model, so based on the prompt engineering, so we can have scoring, or we can have the model can be able to suggest the name for the function, because some of the function after decompiling, after reverse engineering, the type of the function is not very well. For example, for the first one, it's A1B, but the model today, based on the function, the concept of the function, the suggest name decrypt string. This is other interesting framework. So again, we have a pre-processing. So this framework also is related to Android 5. So here we have we take advantage of the compiling tools, decoding tools to extract the source code from the Android file. After extracting the features and the source code, we have the feature engineering. So in the feature engineering also we have a pre-processing to extract and splitting different type of the section of the source code, and in the last phase we try to take advantage of rural method as a partial fine-tuning to train the model for malware analysis detection for Android 5. So I just try to show you guys how we can take advantage of the LMs for source code analysis, especially for malware code detection. And the other thing is related to data set for fine-tuning. So currently the most of the LMs, we don't have a powerful LM for malware code generation or for malware code analysis. Maybe it's a good topic for researching, for fine-tuning or pre-training LM to make LM specifically for the malware code detection, for the malware code analysis. And the other important thing is about the malware dataset. So as I mentioned, one of the challenge for the cybersecurity is about the malware dataset, especially for the software security. So we can take advantage of different techniques such as jailbreaking or rewriting the code for generating the malware and prepare a dataset to evaluate our model. So, okay, I think it's my last slide. This is my reference. Okay, if you have questions.
Thank you, Hamid, for the presentation. So, question? Yeah, 5 minutes.
Yeah.
Hey, thank you so much for the presentation, Hamid. That's wonderful. I have a question. If an adversary knows that you're going to be processing their malware with large